Welcome students to the first lesson of Unit 4. And even though we've been doing quite a bit of algebra this year, this is our first official algebra unit. And we're going to start it off by just getting ourselves grounded in some of the vocabulary that we will be using as we move through our work with algebra. So your learning target this lesson is I can name and identify all of the parts of an algebraic expression. So here's an example of an expression, and it's algebraic because we have variables in it. But let's talk about what an expression is versus an equation. The first thing you want to say is that expressions can be simplified but not solved. And that's something that I've seen students struggle with throughout this unit in the past, is they really want to solve for what x or y equals. But because expressions do not have an equal sign, there's really only so much you can do with them. And sometimes that leads to a little bit of a feeling of non-closure for some kiddos, but just trust us with this. Simplifying is awesome. The first part of an expression we're going to talk about right now are terms. Terms are a single mathematical expression within an expression or equation. Terms can be positive or negative, depending on if there's an addition or subtraction in front of them. So if it's an addition, it's going to be a positive term. If there's a subtraction operation in front of them, it will be a negative term. And terms can have either a written or an invisible coefficient. And coefficients are another piece of vocabulary that we will talk more about in just a second. So for now, just go ahead and take notes about this. So terms can have a written or invisible value of one coefficient, and they may or may not have one or more variables in them. Some of the common variables we will be using and some of the common terms that you will see are terms with x, y, xy, and 1, or all other numbers. We'll also be seeing x squared and y squared. So these are all common terms we will be using. And in your notes right now, I want to circle all of our terms. So in this expression, we have one term right here, and it's a positive 5. We have another term right here, a negative 2y, and another term right here. And since there's nothing in front of it, that's a positive, so we'd actually say that is a positive x. So there are 3 total terms. Next, let's talk about variables. The variables in this expression are x and y. Go ahead and get those highlighted and labeled in your notes. And variables can be any letter in the alphabet. In our last unit, talking about proportional relationships, we saw variables as D representing distance, R representing rate, T representing time. We've seen C to represent the number of cans. We've seen N. It can be any single letter, though we do typically most often use X and Y. And variables are called variables because they vary, because they change. And this will often depend on the situation. But variables are also like placeholders for numbers that we just don't know. And typically, if you see two different variables, like in this case we have an x and a y, those different variables will each represent a different value. So now let's get back to this word coefficient. The coefficients for this expression are 1 and negative 2. And if you go back to that first pieces of vocabulary, we're talking about terms, we talked about this invisible 1, and here's an example. This x has an invisible 1 in front of it. And so we'd say that that is the coefficient 1. I want you to go ahead and in your notes, highlight them a different color from your variables. So I'm going to include the negative in that. And then also, not only does this 1 have an invisible 1 in front of it, but since there is no negative in front of it, that means it's a positive 1. So you can go ahead and draw a positive 1 in there too, and highlight those, and get those labeled. So what coefficients are is they're positive or negative numbers that represent how many sets of a variable you have in any given term. And coefficients represent the operation of multiplication. So in our first term here with the coefficient of positive 1, that is like saying 1 times x. In that second term of the coefficient of negative 2, it's like saying negative 2 times y. And then the coefficients of 1 and negative 1 are invisible. An example of that, like we saw up above, would be x. That's actually equal to 1x, or you could say negative y, which is equal to negative 1 times y, or you could say negative x squared, which is just negative 1 sets of x squared. The last piece of vocabulary we're going to talk about are our constants. The constant for this expression is 5. Go ahead and get that highlighted in a different color, in this case positive 5. And constants are the term in your expression that do not have a variable. They are called constants because they do not change value. That's what being constant means. Remember, constant of proportionality meant something that was that number k that was constantly showing up. Here we have a constant, which is 5, because it doesn't have a variable, so it's not going to change value. It's constant. Working with this same expression, I want to show you what it means that we can simplify but not necessarily solve. If we are given a value to replace one of our variables with, there is some math we can do. So for example, we could say simplify when x equals negative 3. We can rewrite this expression then, and instead of an x, we could write negative 3 minus 2y plus 5. And there's nothing we can really do with that negative 2y. But at this point, we can take our negative 3 and 5 and combine those. I can move this around and say that this is negative 2y. I'm just going to move that negative 3 to the end and say this plus 5 minus 3, and 5 minus 3 is 2. So as this simplifies down to negative 2y plus 2. I'll do one more. What if it says our y is 7.5? In this case, we can rewrite our expression, x. Instead of a y, I'm going to put 7.5. So x minus 2 times 7.5 plus 5. Right? That's saying my coefficient is negative 2, which means I have negative 2 sets of 7.5. I can go ahead and calculate this out. X, then negative 2 times 7.5 is 15. So x minus 15 plus 5. And then I could simplify a little bit further. If I have some number x and it is subtracting 15, and then I add back 5, I can say negative 15 plus 5 is 10. So x minus 10. That's as simplified as this can get. I'm going to leave this last one to you. Simplify when x equals 2 and y equals negative 2. Go ahead and replace those variables and try simplifying down as much as you can. So in my first step, I replaced x with 2. And in my second step, I replaced y with negative 2. And then I started simplifying. So negative 2 times negative 2 is positive 4. So that switched to 2 plus 4 plus 5. And I could simplify that all down further to 11. So sometimes when you simplify, you will come up with just one number. It doesn't necessarily mean you solved anything. It just means you were able to simplify down to a single number. All right, go ahead and try your journal problems. Let us know how we can help you, and good luck.